Started. Um, well, there's not going to be any real prep here. The sanitation obviously is going to occur because this is cooking. We don't want to be dirty like that. Anyways, so there's not going to be any scientific method. What a scientific method would be is the the process in which you trying to isolate a variable as much as you can. In this case, there's not much isolation occurring since it's open air and there's not much in terms of controlling the substances that are going in and out, considering the situation. This is in a lab, so scientific method in this case would not be very effective. Well, the plan put in place would not be very effective. And so what we're doing right now is we're mixing the flour with the maize with all the other ingredients and stuff. And to a certain extent, this could be seen as the mole ratio, because the maize and the flour and the salt, they can be seen reacting with each other. Well, they can't be seen reacting with each other, but they will react with each other once water activates them as an ingredient. And so a mole ratio, that's just the amount of substances that are combined to create a different substance. But what a mole itself is, a mole is a measurement. It's how it's a certain amount of atoms that we use to be able to that we use in science for practical reasons, because an individual atom is very hard to measure, so it'd be very impractical to measure things by individual atoms. And so instead we use this amount of atoms, 6.022 times 10 to the power of 23, which is also known as Avogadro's constant, to ensure that we have a universal way to measure atoms, but that is also practical. And so after we mix the water here, you can see that this became dough. That this is no longer just a powder, and that's due to water's properties. Water is polar. It has a negatively charged and positively charged regions, and so this allows the formation of the certain type of bond. It's called a hydrogen bond. And so a hydrogen bond is it's a very weak bond, but it's very flexible, and it allows for these types of substances to occur. The dough, it can easily move, but it's sticky, and it's just in general very easily molded to be the way you'd like it to be. But the issue with a hydrogen bond is, again, it's very weak, which is why you can split dough so easily. And what the bond that forms between the atoms of flour would be a covalent bond. That's why flour is more stable. A covalent bond is instead the sharing of electrons instead of the attraction of different charges. And the last bond present here, or at least the last bond in the mixture, is an ionic bond. An ionic bond is the bond that is holding together the salt. The ionic bond is allowing the formation of ionic compound. But what an ionic compound is itself is just a cation and anion come together due to the difference in their charges, which causes an attraction, a very strong attraction between the two. A cation is a positively charged atom or compound, and an anion is a negatively charged one. And so this allows the formation of a very strong bond. But this type of bond also results in a very brittle substance that is usually seen in a crystalline form. That's why salt is seen as like that granule crystal-like form in its normal state. And again, what brings these different substances together is the water. And water has these two properties. It's adhesion and cohesion. Adhesion is the ability or tendency of a substance to cling to another or to attach itself to it. In water, this is due to its hydrogen bonds. It clings to surfaces because it easily forms those bonds. Although they may not be strong, it still forms that attraction and allows it to be adhesive. Cohesion is instead the attraction of the same molecule, or the same type of molecule, to itself. So that'd be like two water molecules. And so the adhesive nature of water in this instance is holding together these different substances, the flour, the salt, the maize, all of that. And the cohesion it's just mingling. It's there, and it's convenient because it means the water won't repel itself and make these clumps instead of this dough, this more consistent dough, instead of forming little balls, because the different water molecules, while they may be adhesive to a different substance, they are not adhesive to itself, and so it solves that issue. When these two types of forces and patterns and tendencies are combined, it can form this thing called capillary action. Although this isn't seen in the dough, it's how water can flow through a tube that is going up against gravity, because the adhesive nature of it is clinging to the walls of the tube, while the cohesion of it is pulling the water up as the other water travels up the wall. And a third unmentioned tendency is also surface tension. Surface tension is the ability to resist overflowing or spilling over from when you overfill, and it can be seen when you overfill a cup of water. It can go above the brim without flowing out. That's surface tension. That's its resistance to bursting its bubble. And if you were following along, you may have noticed that the flour, the dough, it's not very good for what we're doing. It keeps on sticking to the surface. It keeps on sticking to the plastic, and that's a physical feature of flour. So when you add more flour than maize or another component, it causes this ratio to be very sticky, and it does not work for what you're trying to accomplish with making tortillas, because you don't want it to stick to the pan or stick to the plastic while you're expanding the dough and such. And if we skip ahead a little and ignore the socks and sandals, we'll see a chemical reaction occurring. It may not be very visible on screen, but there's smoke and heat, which is caused by the stove, so it may not be a very good indicator. But this getting inflated, it's changing, and you can see the smoke more clearly now. This is a chemical change occurring, a chemical reaction. The dough and its contents, it's being cooked and it's being transformed into a different substance. That's what happens when you go from raw to cooked. You're having a chemical reaction. In most situations, it's in an attempt, with meat at least, it's an attempt to kill the bacteria that inhabits the meat that could be harmful to the body, and killing the bacteria is a chemical change. Now, if we skip ahead even a little more and use the cheat fork, because usually, you use your hands, but in this case, the dough, it didn't come out right, so it's sticking to the pan. Once this is flipped, you'll see that it's cooking unevenly. Now, this is occurring, or it may be an indicator that the dough, it's heterogeneous, it's heterogeneous. It is not evenly, it doesn't have its substances evenly distributed. This is why you see some specks in some regions being darker than others, because there are different substances there, so it's cooking different. And here we're fixing the mixture, the heterogeneous mixture. A different type of mixture would be a homogeneous mixture, and that would be a mixture in which substances are evenly distributed. So it'd be like a bottle of water. If you don't count the pollutants included in that water, it is relatively evenly distributed across. It's mainly pure water. Anyways, when making dough, use a recipe. That was the issue. We used too much flour. It got too sticky. Stick to maize as the priority, because you got to knead flour. That's a whole different situation. That's kind of how you make tortillas, and you'll see in a second. It even cooks different. These are bigger bubbles and fewer. The dough looks different, which is actually another physical trait. The color itself, it looks different. It's tinted differently, and it's overall very different from what you had seen before. And it's less sticky. It's not going to stick to the pan when you try to flip it. You don't need the fork of shame. And just give it a say. Yeah, right there. Yeah, see, I mean, they got stuck a little, but like overall, it's a lot better. There's not even smoke coming out of it because it's a different reaction occurring. And now, please forgive me, but I'm about to use a microwave to heat up my food because at this point I was very famished. So at this, I just wanted to reheat something. So I'll make quesadillas, but I'll just reheat this instead. Anyways, a microwave is actually using this thing called microwaves. They're actual microwaves. Those are types of waves that are found on the electromagnetic spectrum, and they have a much longer wavelength than they do frequency because and the different wavelengths and frequencies cause different properties, and we can't see microwaves, but like we can see this fire. This is creating a portion of the electromagnetic spectrum we can see. It's the light spectrum. It has a higher frequency than microwave, but the higher frequency doesn't necessarily mean that we're going to be able to see the wave or frequency. There's only a specific portion of the electromagnetic spectrum that we can see. And in this case, the waves we're seeing are the waves that are being emitted from an electron becoming excited, then returning to the ground state. Magnesium creating a white light because that return to the ground state emits a wavelength, and that emits the light.